Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good day to everybody. Okay, so for today's lesson, we are going to talk more on quadratic functions under the subtopic analyzing the effect of changes of a, b, and c towards the shape and position of the graph for fx equals to ax squared plus bx plus c. And then we are going to look at relating the position of the graph of a quadratic function and the type of roots. Okay, let's begin. Okay, so first thing first, let's explore. Okay, so from inquiry 4, okay, our aim is to explore the effects of changes in the values of a, b, and c towards the shape and position of the quadratic function graph. Okay, so we need to observe the graph of function in which the a is 1, b is 2, and c is 3. Okay, and then we need to analyze the change of the shape and position of the quadratic function graph based on the following instruction. Okay, for a, we need to drag the slide left and right without changing the side b and c. And for b, we need to drag slide b to the left and right without changing side a and c. And next, for c, we need to drag the slide left to the right without changing side a and b. Okay, and then we need to make a generalization on the effect of changes in the values of a, b, and c on the shape and position of the graph of fx equals to ax squared plus bx plus c. Okay, so let's explore together. Okay, so this is the graph. Okay, this is the graph. Okay, for x squared plus 2x plus 3. Okay, so first let us try for a without touching b and c. Okay, if we drag a to the right, so that means that the value of a become more than 1. So what happened? Okay, look again. Okay, this is when a equals to 1. So this is the graph, the quadratic graph for x squared plus 2x plus 3. What about if we have 2x squared plus 2x plus 3? What happened to the graph? Okay, the graph becomes smaller, right? I mean, it's not smaller lah. The width become smaller. Okay, the width of the graph becomes smaller. If we drag more, you see, the bigger the value of a, the smaller the width of the graph. So we can make hypothesis that how about when we drag a to the left? I mean less than 1. Okay, so our hypothesis, it must be the opposite, right? So if greater than 1, the width becomes smaller. So our hypothesis will be, if the value of a is less than 1, it will become bigger lah. The width. Okay, the width of the graph will increase. So let's look at it. Okay. See? Where's the graph? Okay, the graph is there. Okay, remember, when a is negative, it will become maximum graph. Okay, it will become maximum graph. So it will be down here. Okay, let's look at it. Okay. So this is when a negative 3. So our hypothesis before, we said that when a greater than 1, the width become smaller. So when a less than 1, we said that it will become bigger, right? So the result seems like, oh, it's not become bigger. It's still, the width will become smaller. However, the graph will become maximum. Okay, the graph will become maximum. Okay, before our graph is minimum graph because we have minimum point. However, when A becoming negative, okay, when A becoming negative, our graph became maximum. Okay, and then the value, okay, when A is more than negative 2, I mean less than negative 2, the width became less than negative 1 or less than 1, the width is still will become smaller. Okay, see? See? Okay. Okay. So that is case A. How about B? Okay, our B now is 2. Let's drag it to the right. Okay, you see? The graph move. Okay? Okay, before, the graph doesn't, the graph maintain the same, right? Just the width, right? The changes in width, right? However, when we change B, the graph doesn't change the size. But the graph moves. Moves where? When it is more than 2, the graph moves to the left. Okay, see? Okay, the graph moves to the left. Okay, how about when B less than 2? See the movement? The graph moves to the right. Okay, so that is for case B. Okay, case B. Greater than, it moves to the left. Less than, it moves to the right. How about C? Our C now is 3. How about C greater than 3? Oh, it moves upwards. Okay, it moves upwards. Okay, we know that C is y-intercept. So when we say that C is equal to 6, therefore it moves upwards 3 units, from 3 to 6. So how about when C less than 3, it moves downwards. Okay, you see the difference? Okay, when we talk about A talks about the width of the graph. Okay, the symbol or the sign of A, positive or negative, just states that the type of graph, maximum or minimum. If it is positive, the graph is minimum, and if it is negative, the graph is maximum. However, the bigger the value, the smaller the width become. Okay, the smaller the width become. However, when we talk about B, when B is greater than certain value, it will change the position of the graph. Okay, it will move to the left. Okay, when B is bigger, it moves to the left. However, when B is smaller, it moves to the right. So, does C. When C is bigger than certain value, it moves to the upwards. It moves upwards. So C change the position of the graph. Okay, when the value is smaller, it moves downward. Okay. Okay. Okay, so let's look at our result. Okay, so this is the original graph for our equation, which is fx equals to x squared plus 2x plus 3. So, okay, see, change in shape and position of the graph for quadratic graph, right? Okay, when we change only the value of A, change in value of A affects the shape and width of the graph. However, y-intercept remains unchanged, of course. Okay, we have proven before. Okay, we have looked at the graph. Okay, how the graph changed, how the graph from certain width became smaller. Okay, from certain from maximum or from minimum graph change into maximum graph. So it affects the shape and the width of the graph. Okay, when a greater than 0, when a is positive, the shape of the graph is minimum, which passes through the minimum point, and when a is negative, the shape of the graph is maximum, which passes through the maximum point. Okay. For the graph of a greater than 0, for example, a equals to 1, when the value a is larger than 1. Okay, for a greater than 0, when the value a is larger than 1, the width of the graph decreases. Okay, we have shown to you that the width of the graph decreases. Okay, conversely, when the value of a is smaller, it is smaller than 1 and approaches 0, the width of the graph increases. Conversely, when the value of a is smaller than 1 and approaches 0, the width of the graph increases. Okay. For the graph a less than 0, for example, a negative 1, the value of a is smaller than negative 1, so the width of the graph decreases. Conversely, when the value of a increases from negative 1 and approaches 0, the width of the graph increases. Okay, let's look at the graph. Let's look at the graph. Okay, so this is case a greater than 0. Okay, when the value become bigger, so the width become smaller. Okay. Okay, this is when a less than 0. Okay, in this case, the value of a is negative 1. So the size of the width is the same as the original one. However, if I were to put it at a negative 2, let's say a negative 2, the graph will become smaller. Smaller gitu. Okay, will become smaller. The width of the graph will become smaller. Okay, the width of the graph. Okay, so basically the y-intercept is the same. The y-intercept is the same. It's just that the width of it is smaller. Macam ni lebih kurang. Okay. Okay, next. Let's look at another part. Okay, this is the original. Okay, let's look at the changes in B. Okay, change in value of B only affects the position of vertex with respect to the y-axis. Okay, however, the shape of the graph and the y-intercept are unchanged. Correct. Okay, when B equals to 0, the vertex is on the y-axis. Okay, let's look at it. Okay, see, this is B equals to 0. So the vertex is on the y-axis. Okay, the vertex is on the y-axis. However, when a greater than 0, for graph a greater than 0, graph positive, when b greater than 0, the vertex is on the left side of the y-axis. Okay, and when b less than 0, the vertex is on the right axis, on the right side of the y-axis. Okay, see, this is when b greater than 0. So it moves to the left. Okay, for the second one, when b less than 0, so it moves to the right. Okay, and this case, both cases is for maximum graph. How about minimum graph? Okay, how about minimum graph? For a less than 0, it states that when b greater than 0, the vertex is on the right side of y-axis. However, when b less than 0, the vertex is on the left side of the y-axis. Let's see. So this is a less than 0. So b here is positive, greater than 0. So it moves to the right. Okay. And this is when b is negative. So it moves to the left. So as you can see, it is the opposite between maximum and minimum graph. Okay, if you remember the minimum one, so for the maximum one, just the opposite of it. Okay, remember for b, the shape and the shape of the graph and the y-intercept doesn't change, but it changed the position of the vertex with respect to y-axis. Okay, next, how about change in C? Okay, this is the original one. Okay, change in value of C affects the position of the graph either vertically upwards or downwards. The shape of the graph is unchanged, of course. Okay, let's look at it. Okay, this is for when C greater than 1, this is A greater than 0 and C greater than 0 lah. Okay, greater than 0. Okay, so we can say that, oh, it moves upwards. Okay, how about when C less than 0? Okay, so this is for A greater than 0, but C less than 0. So it moves downwards. Okay? Okay? I hope you can understand. Remember, A change the position, changes in A change the shape of the graph and change the size of the graph, but it doesn't change the position of the graph. Okay, and the y-axis, the position of the graph is changes when A less than O. But okay, A changes the position of the graph and the shape of the graph. However, the y-intercept is the same. Okay, but B change in B change the position of the graph, but it doesn't change the shape and it doesn't change the shape. Okay, it doesn't change the shape because it moves to the left or move to the right based on the y-axis. Okay, change in C will change the position of the graph. Okay, will change the position of the graph, but the shape of the graph is unchanged. Okay, that's it. Okay, let's analyze. Okay, let's analyze. Okay, example 1. The diagram shows the sketch of the graph for fx equals to x squared plus 1. Okay, where a equals to 1, b equals to 0, and c equals to 1. Make an analysis and a generalization on the shape and position of the graph when the following values change. Hence, sketch the graph. Okay, when the value of a becomes 2. Okay, remember when we talk about a, okay, when we talk about a, it change what? Change the shape and size. Okay, change the shape and size of the width of the graph. Okay, when we talk about change of the shape, look whether A is positive or negative. Okay, when the size, look at the value of A, whether it's greater than this number, our A is 1 now, okay, it becomes 2. So which means when it becomes 2, we know that the width increase or decrease? The width will be decrease, right? The width will be decrease. So what about 2? Half. A become half. So we know that half is smaller than 1. So if the number which is bigger than 1, the width become smaller. So this will be increase in width. Okay, let's look at the answer. Okay, see? When A changes from 1 to 2, the width of the graph decreases. Okay, from 1 to 2, the width of the graph decreases. The y-intercept doesn't change, and the vertex is on the y-axis. See? Okay, from the dotted is the original one. Okay, it became smaller. The width of the graph became smaller. So the blue one is the new one. Okay, the blue one is the new one. So from A to 1, so the final here is 2x squared plus 1. Fx is equal to 2x squared plus 1. So how about B? When A changes from 1 to half, the width of the graph increases. Okay, increases. The y does not change and the vertex is on the y-axis. Okay, y does not change and the vertex is on the y-axis. So as you can see here, the dotted one is the original one. So we know that the value of A is less than the original value of A. So we know that the width of the graph will increases. So this is our new function when A changes. Okay, greater value of A, the width smaller, decrease. When the value of A is smaller, the width increase. Okay, how about B? Okay, B, the value of C becomes 3. So C greater than 0. So when we talk about change in C, we are talking about the position of the graph. Okay, change in position of the graph. Okay, whether it moves upwards or downwards. So when C is greater than 3, therefore we know that, it moves upwards. Okay, it moves upwards. I mean, it's not C greater than 3. Our C here is 1 and then becomes 3. So we know it moves upwards how many units? 2 units. 2 units. Because from 1 to 3, 2 units. So what will happen? Okay, see? Okay, when C changes from 1 to 3, the shape of the graph remains the same. Okay, remains the same. Only the change in the position, that is, it moves 2 units upwards. So the dotted one is the original one. And then it moves 2 units upwards. So this is our new graph, which is fx equals to x squared plus 3. So simple, right? Okay, I hope you can understand this. Okay, let's move on. Relating the position of the graph of a quadratic function and the type of roots. Okay, let's explore. Okay, so we have 2 cases, in which the case 1 is for when a greater than 0 and case 2 is for when a less than 0. Okay, by using a geometry software or whatsoever, plot the graph of each quadratic function in the case chosen. Observe the shapes of the graphs obtained and the respective roots. State the relation between the value of b squared minus 4ac types of roots and the number of intersection points on the x-axis. From the relation, state the position of the graph of the quadratic function obtained. Compare the findings. Okay. So, let's say x squared plus 4x plus 4. Okay. By using the software that we use in the first exploration in query 4, okay, so I have drawn it for you. Okay, so for case 1, this is our graph when a equals to 1, b equals to 4, and c equals to 4. So the function actually is fx equals to x squared plus 4x plus 4. Okay, so before we have learned about type of roots of quadratic function. Remember, when we talk about type of roots, we have 3 type of root. First, 2 different real roots. And the second one, 2 equal roots. And the third one, no real roots. Okay, again, when we talk about type of roots, we will relate it with b squared minus 4ac, the discriminant. So, for 2 different real roots, b squared minus 4ac must be greater than 0. For 2 equal roots, b squared minus 4ac, the discriminant must be equals to 0. And the last one, for no real roots, b squared minus 4ac must be less than 0. So, from this graph, we can see that, oh, this graph, okay, let me change the color of the ink. Okay, let's say, okay. Oh, we can see that, oh, it touches one value here. Tukar ke tak ni? And there. Okay, it touches at one. Tak kisahlah. Okay, so it touches at one value. Okay, it touches at one value. So we can say that, oh, from this graph, this is the type where we have 2 equal roots. So when we talk about 2 equal roots, we relate it with discriminant equals to 0, right? Okay, discriminant equals to 0. So what is the value of the x-intercept? From graph, of course, we can see that, oh, this is x equals to -2. What if we don't have the graph? We just have the function. What if we don't have the graph? We just have the function. How can you find the value of x-intercept? How can you find the root of the quadratic function? So remember, when we talk about x-intercept, sorry. Okay, when we talk about x-intercept lies on the x-axis. So our y equals to 0. So what we are going to do in order for us to find the value of x, so substitute y equals to 0. So x squared plus 4x plus 4 equals to 0. So we know that when we want to solve for quadratic equation or quadratic function, we need to use factorization or formula or completing the square. So since this is the simple one, so I use factorization. Okay, so this must be 2. Okay, this is 2x, this is 2x. So add both of them, so 4x. So we have our factors is x plus 2, x plus 2. So our value of x is -2. Okay, this is just extra. I just give you extra here. But from here, we can see that, oh, it's just the value of x is at 1 point, which is -2. So we know that, oh, this is 2 equal real roots. Okay, 2 equal real roots. So we relate it with b squared minus 4ac equals to 0. Okay. In other words, okay, or we can substitute the value of b. A and C. Okay, so let's say we said that, oh, B squared minus 4AC. So our B is 2 squared. Bukan 2, 4. Minus 4 times 1 times 4. So basically 16 minus 16. So we have 0 lah. Okay, so this is relating the position of the graph with the type of root. Okay. Next, how about the second one? Okay, the second one, we can see that, oh, we have two values of x, different values. So we said that, oh, this is case two different real roots. Okay, two different real roots. So when we talk about two different real roots, we relate it with discriminant greater than 0. Okay, here. Okay, how about the next one? Okay, the next one, if we look at the graph doesn't touch the x-axis. Doesn't touch the x-axis. So we know that, oh, therefore we have no real roots. So we will relate it with discriminant less than 0. Okay, this is case 1, in which all the graph is a greater than 0. So you see that when a greater than 0, when a is positive, all the graph is minimum graph. Okay, when a greater than 0, so graph minimum graph. Okay, next, case 2. Case 2 is for a less than 0. So the graph will be maximum graph. Okay, again, let's look at the first graph. Okay, so the first graph touches the x-axis at one point. Okay, touches x-axis at one point. So when we see this kind of graph, so we know that, oh, it has two equal real roots. So we relate it with discriminant equals to 0. Okay, so the next graph, it touches at two different values of x. So touches the x-axis at 2 points. So we know that, oh, this is two different real roots. So we relate it with discriminant greater than 0. Okay, how about the last one? Okay, the last one doesn't touch the x-axis. So we know that, oh, we have no real roots. So we relate our discriminant must be negative. Okay, so this is just what we've learned before, the type of roots of quadratic function. Okay, so this is simple lah. Okay, simple one. Okay, so as conclusion, relation between position of graphs of quadratic function fx equals to ax squared plus bx plus c on the x-axis and the type of root. Okay, so when b squared minus 4ac greater than 0, when discriminant is positive, we can see that, oh, the type of root is two real and different roots. And the graph intersects at x-axis at two different points. Okay, this is for graph positive, minimum graph. Okay, minimum graph touches at two different points. And this is for graph a less than 0, in which it become maximum graph. Okay, this is minimum graph. And this will be maximum graph. Okay. Okay, when discriminant equals to 0, we know that our type of root is two real and equal roots. and the graph touches the x-axis. Okay, this one at 2 points. The graph touches the x-axis at 1 point only. Okay, so this one and this one. Okay, so this is, if you were asked to sketch, so this is what comes in your mind. Okay, supposedly this is the shape that should come in your mind. Okay, the main important thing is the x-axis. Okay, so when the discriminant less than 0, we know that, oh, the type of root is no real roots, and the graph doesn't intersect at any point x-axis. See? Okay, this part doesn't touch. Okay, doesn't touch. Okay, so this is the conclusion for relating position of the graph on the x-axis, okay, and the type of roots. Okay, let's look at example 1. Determine the type of roots for each of the following quadratic functions when fx equals to 0. Fx equals to 0 means that y equals to 0. It means that it is x-axis. The line is x-axis actually. Okay, then sketch the graph and make a generalization on the position of the graph at the x-axis. Okay, so this kind of question, it asks what will it be when this function intersects the x-axis. Okay, intersect fx equals to 0. What will happen? Okay, it asks us the type of root. Okay, so what kind of roots do we have? And then sketch the graph. Okay, so first of all, when we talk about type of roots, of course, we are dealing with discriminant. We will relate it with discriminant. Okay, again, for two different roots, discriminant greater than 0. For two equal roots, discriminant equals to 0. For no real roots, discriminant must be less than 0. Okay, so first of all, we need to find the discriminant. Okay, so first of all, determine our A, B, and C, and then find the value of the discriminant. So in this case, for A, we have our discriminant is equals to 41, which is greater than 0. So we said that, oh, this is two different real roots. So that means when two different real roots, we have 2x intercept. Okay, so let's look. The quadratic function has two real and different roots, of course. Okay, since a greater than 0, does the graph, okay, a greater than 0, so the graph is parabola which passes through the minimum point. So, senang cerita, minimum graph lah. And intersect the x-axis at 2 points, of course. Because we said that we have two different real roots. So, how can we sketch? Just sketch. Okay, sketch. Because it doesn't ask for the value of roots. It just asks for type of root and sketch. So, just sketch like this. Okay. Okay, how about B? When we find the value of the discriminant for function B, we found out that, oh, discriminant equals to 0. So that means our type of root is two equal real roots. So when two equal real roots, it touches at 1 point. So we have only one x-intercept. Okay. So the quadratic function has two real and equal roots. Okay, since a less than 0, okay, a less than 0, thus fx is a parabola which passes through the maximum point and intersect the x-axis at 1 point. So it wants to say that, oh, our graph is maximum graph. So sketch. Our graph will become like this. Simple, right? Okay. Simple, right? Okay, next. Find the values of Q. Okay, find the values of Q. Q is equals to Y, for which the x-axis is a tangent to the graph of quadratic function. Okay, the keyword here is tangent. What is tangent? Tangent is a straight line that touches one point on a curve. Okay, touches one point on a curve. So we know that our function is quadratic, right? So let's say we have quadratic here. Let's say this is our fx. So this fx touches a tangent line. So we have this point. Okay, this is a point, right? xy. And then, okay, this is tangent line. Okay, in which tangent line is another function, let's say gx. Okay, so in this case, we know that, oh, it touches at one point. So relate like, if we relate all the things that we have learned in this topic, the type of roots, okay, what type of roots in which it touches at one point? What type of root? What type of root that touches at one point? Of course, it will become two equal real roots. So, the keyword here, tangent, it wants to relate with two equal real roots. So, when we talk about two equal real roots, how about the discriminant? The discriminant must be equals to 0. Okay, the discriminant must be equals to 0. So, that is the main thing. Okay, so how can we solve it? We need to solve discriminant equals to 0. But first thing first, we need to identify the value of a, b, and c. So, from the function, we can identify the value of a, b, and c. Okay, so this is our function. Fx is equals to qx squared minus 4x plus q minus 3. So, our a is q, b negative 4, c q minus 3. And then substitute the values of a, b, and c into discriminant equals to 0. Okay, so substitute correctly. And then we expand. Okay, expand. Okay, as we can see here, at first, our q squared is negative 4. Okay, so as we can see, 16, negative 4, and 12, we can simplify it with multiples of 4. So, we divide all the equation with 4. So, we have negative q squared plus 3q plus 4 equals to 0. And then we solve the quadratic equation by using whether factorization formula or completing the square. So, we will have our value of q is 4 and q is negative 1. So, that is the answer for q. Okay, simple, right? Okay, the main thing, you need to identify the type of root. Okay, look for the keywords. Okay, let's look at the next example. Find the range of values of q. Okay, when we talk about range, there are only two types of roots that deals with range. Whether discriminant greater than 0 or discriminant less than 0. So, whether it is two real roots, two different real roots, or no real roots. Okay. So, find the range of the values of q for which the quadratic function has two x-intercepts. So when we say that two x-intercepts, that means we are talking about two different real roots. So since it's two different real roots, so we relate it with discriminant greater than 0. So that is why, since it involves inequalities which is greater, that's why the question asks for range. Okay, the same thing. Okay, identify the value of A, B and C first, and then substitute in discriminant greater than 0. So what will happen? Okay, so our A is 2, B negative 8, and C is 3 minus Q. So we substitute in discriminant greater than 0. Okay, so expand. So we will have 8Q plus 40 greater than 0, which means 8Q is greater than negative 4. Okay. Okay, so our Q is greater than negative 5. Okay, our Q is greater than negative 5. So this is the range of Q. Okay, this is the range of Q. Okay, simple. Okay, next, example 4. Find the range again. Range. So whether b squared minus 4ac greater than 0 or b squared minus 4ac less than 0. Find the range values of k for which the quadratic function fx equals to k plus 2x squared minus 2 times 2k plus 1 of x plus 4k lies entirely above the x-axis. Okay, so if we sketch the graph will be like this. Okay, the graph will be like this. Okay, this is x-axis. So we know that, oh, this is the type of no real roots. So when we talk about no real roots, we are talking about discriminant less than 0. So this one. Okay. So the same thing, identify the value of A, B and C and then substitute in discriminant less than 0. So, okay, our A is k plus 2, B is negative 2 times 2k plus 1 and C is 4k. So we substitute in discriminant less than 0. Okay, so we need to do expand here. Expand. Okay, so expand correctly. So we will have negative 16k less than negative 4. Okay, remember, when we talk about coefficient negative, okay, this is negative coefficient. So we know that, oh, we need to divide with negative 16 lah, kan? So when we divide with negative numbers, the sign will change. Okay, since coefficient of k is negative. Okay, so we will have k greater than. See, from less than it became greater than. So what is our range of values of k? So k must be greater than 1/4. Okay, remember, when we have coefficient of certain unknown negative and it involves range or inequalities, the sign of the inequality will change. Okay, so that's why our answer is k greater than 1/4. Okay. Okay, so this is for evaluation. Okay, I would like you to do these 2 questions and remember to discuss your answer with your teacher. Okay, and then this is for today's homework. Self-practice 2.6, self-practice 2.7. Okay, class. Okay, remember, so as a conclusion for today's lesson, we've learned that we have relate the position of the graph on the x-axis with its type of graph. Okay, remember, when we have the graph, we have 2 x-intercept. So we know that the type of graph is 2 different real roots. So we relate it with discriminant greater than 0. However, when the graph have only 1 x-intercept, So we know that the type of root is 2 equal real roots. So b squared minus 4ac equals to 0. And the last one, when the graph is entirely above or below x-axis, basically we said that it doesn't touch the x-axis. So we know that the type of root is no real root. So the discriminant must be less than 0. Okay, so before I end up my session, class, mathematics has beauty and romance. It's not a boring place to be, the mathematical world. It's an extraordinary place. It's worth spending time there. Okay, I hope you can understand this beautiful phrase. So all the best and thank you for your commitment. Before I end up my session, I hope you guys stay safe, stay healthy. Peace be upon you. Thank you.